Hey, hello, and welcome to the show. We've got an echo. That should take care of that. Maybe now? Maybe now. Ooh, that's a new one. Hold on 1 second. It's always an adventure. Let's change this to system default. Hey, that's better. Woo! That was going to be cuckoo. So hi, I'm John Park, and this is JP's Product Pick of the Week. Here we are again. It's Tuesday. And as you might have noticed from the wackiness going on with my audio there, I was noodling with settings, trying to see if I could fix some slowdowns that we were getting. So let's see. Hello, Davidessa and David Lindy's over in the YouTube chat, and then all the good people over in our Discord chat. Hi, C. Grover, Mr. Certainly, woo-ha! 007, Jim Hendrickson, Susan made it. Hello. Hey, Dexter Starboard. So if you're wondering where the chat is, by the way, if you're over on Facebook or Twitch or one of the other streaming services that doesn't appear to have anyone chatting on it, then you might want to go head over to the Adafruit Discord. That's at adafruit.it/Discord. You'll get an instant invite, and then you can come on over into the live broadcast channel. How about that? So let's see. The echo was kind of fun, but fair enough, says David Lindy's. Yeah, all right. Enough of that, right? So before I really get started, what I want to do is remind you that we have a big discount on this week's product pick. So if you want to head over to this URL that you'll see listed below, or head over to that QR code by pointing a device, then you will find that we've got a 50% off on this week's product pick. That will also, by the way, spoil the surprise if you're waiting to see the big reveal, which is happening momentarily. Also, I want to say hey to Mark DeVink over in YouTube. Our good friend Mark, nice to see you. It's been a while. All right, so head on over there if you want to watch this video from inside the product page. That's something unique we do. Otherwise, let's get on with it. So let's see. Let me clear that layer out there. And what I'm going to do is have Lady Ada tell us a little bit about this product pick. It's an oldie but goodie, actually. This is a throwback one. This is a favorite, but it's not so new. So take it away, Lady Ada.
This is the PowerBoost 1000C, which is a 500 more C than the PowerBoost 500C. It actually is the same boost converter as the 500C, but it has a much higher quality LiPo charger. So on one side, you have a boost converter that can definitely give you 1,000 milliamps from a LiPoly or lithium-ion battery. Just make sure you have a big chunky battery, because 1 amp is a lot to draw. I mean, after boosting, it's going to be like 1.5 amps from your battery. So these large 6,600 milliamp hour batteries are good. And we also have a spot for you can solder in a USB connector that's included, and we put the resistors on for iOS charge detection, so it works with an iPad. And the PowerBoost 500C doesn't work well with the iPad. This one has we put the resistors on, so it's the 1 amp hour charge, so it'll charge your devices much faster. Just don't forget you actually do have to use like a really big battery for that, because they'll drain very fast. And then on the other half of the board, we stuck a LiPoly charger. So basically the micro USB is to charge the battery, and then you can see the micro USB coming in, and then there's a battery and then going out. So this is basically like a little power pack. You can charge the battery and then disconnect the charger and keep running. So on the left hand you can see there's the charger circuit, and normally we use like a teeny little SOT 23.5 charger, and this time we went all out, and we went with the MCP 73871, I remember the part number, which is a very smart charger. And the smart chargingness of it is what lets us call it a PowerBoost 1000C. So this can charge at a rate of 1 amp at a time, which is much higher than usual. So you can charge the battery very fast. So make sure you're charging it with a port that can give you a full amp. And secondarily, it has load sharing, smart load sharing. So the problem with the 500C is that if you had a battery plugged in and you were charging it and drawing current, any power would come in, charge the battery, and then come back out and go to the booster. And so it wasn't very efficient because you had the battery in the way, and also you couldn't run it without the battery plugged in because the battery was required to kind of stabilize the system. This charger, however, it's a little bit more expensive, but it's smarter. When you plug in the USB connector on the micro USB side, it says, oh wait, I'm charging the battery, so it switches over to, it takes the 5 volts from USB and brings that right out to the boost converter so that like there's no loss of efficiency there. And then any leftover current is used to charge the battery, and so it's much kinder on your battery because it doesn't constantly charge and discharge. And also you don't have to have the battery plugged in, so you can hot swap battery and you can hot swap the USB.
You just solve like 8 billion problems I've seen with people trying to do power for
it's all the Raspberry Pi projects because people like, I was like, oh, you can use the Raspberry Pi, but then I didn't realize people were going to plug all this other crap into their Pi. So now you can actually draw a full amp from it and also charge the battery at the same time and then disconnect, and like you can be a lot more flexible and it won't discharge the battery continuously. This is the 5-inch display, and we've got it connected up to our Pi Keepa that we showed off last week. And then over here I've got the PowerBoost 1000 and 1000C, and you can see I'm just kind of moving my mouse around. And then it's currently charging the battery while also charging the Pi up, like running the Pi. And like just to demo, I can stop charging the battery and everything is still running.
Oh.
And then plug it back in.
So it is like a UPS.
It's like a UPS, and then I can also just disconnect the battery.
Wow. So that's like a magic trick.
And it still works. I mean, like you can basically it's smart enough that it'll take the power from USB, and you can like hot swap batteries.
That's cool that you did a live demo doing that. That's a little risky.
It's a little risky. I mean, look, it still runs. And I was just like, because like one time I did it, and I accidentally kind of like jittered this cable, and it came on. You have to be careful, but as long as you keep either the battery or the charge connected, it'll work.
Okay.
So yeah, this is hopefully going to solve all the problems that people who had with the 500C works great. It's a lovely boost charger converter, but this one's much smarter.
Yes, that's right. It's lovely and smarter. Sorry, I know that video just cut right off abruptly, but we had to stop that one. So let me go and run and grab one from my magical cabinet of mystery drawers. I'll be right back. Yes, the product pick of the week this week is the PowerBoost 1000C. It is a boost that takes your batteries from 3.7 up to about 5.2 volts, so you can run things that are a little bit picky about their power. And it's a charger, and it gives you about an amp. So that's what the 1000 milliamps comes from. And the C means it's charging, if you're wondering about the naming of these power boosts. We have a few of them. This is the top of the line one. And in fact, on this one right here, I can plop this USB port. I didn't solder that on yet. So that's how it'll come to you, and this comes in the bag. You can solder that port on there if you're planning on plugging in a USB cable with the A side into here. But you can also attach a little pair of terminal blocks there or solder directly to it if you're putting this inside of a project. And this has the USB micro B port on it for charging it or running the conversion straight out to your device. And then it has the little JST connector for the battery. So what I want to do, actually, I want to show you a couple things. First of all, why don't we take a look at in the down shooter here. After I flip that, is that better? Didn't want to flip. There we go. So this is our PowerBoost 1000C, and you can see here I have a USB cable plugged into it to run a device. So this is actually a real short USB-C to USB-A cable that I have here. So I can plug that in, and then I can power something like a Raspberry Pi from it. You'll see we have this blue LED that tells us we have a very happy 5 volt coming out of this side, so the device is on. It's running, it's ready to go. You can use the enable pin on here, ground the enable pin, and that will turn the device output off, but it'll still keep charging. So I'll show you a project where I integrated that in a second. You can see here, this is charging right now. It's actually full up because this is the green, the battery is full up LED. So I can go ahead and unplug that. If your battery is charging, you'll get the little yellow LED. And then you can see here I have my battery. This is a 2000 milliamp hour, 3.7 volt LiPo that's plugged into here. And so this one is ready to run something. Now what I want to do is actually, let me zoom out just a little bit here and I'll refocus for you, for all of us really. Let's see, it's pretty close. And I'm going to do something I didn't think would work, but for some reason does, which is I'm going to power a Raspberry Pi 4. And not only is it powering a Raspberry Pi 4, but I've got a display in here, a little Pimeroni square touch, what do they call it? A hyperpixel touch display. It's a little dusty, sorry. So I'm going to go ahead and run my little battery through the PowerBoost, through this USB cable into the C port there. You can see it's started booting up right away. And I can try to angle that so we're not looking at light reflections. And there you can see this is powering up. It's not even showing me the little lightning bolts of doom. There's on the Raspberry Pis, there's a little lightning bolt that'll show up when the power is questionable, when it's dipping. So I'm actually unsure why this works, because I'm pretty sure that we usually recommend a 3 amp supply for these. So I think it could just be that the battery is capable of supplying enough current that it's keeping this happy. Obviously, you're not going to run this for very long on this little battery. I would guess an hour or something on this little battery, but you could go up to a big chonker donker like that right there, and then you would have a nice long life for your little portable Pi system. Now, one cool thing here is that for projects that are drawing more like the 1000 milliamps, the amp that they should be drawing, you can hot swap the battery. So you could plug in the charging here, so this would charge the battery, and then you could swap out different batteries and use it sort of like a UPS. I don't think that's going to work in this case because this little USB cable isn't going to supply the current necessary. Only the battery is capable of keeping this Pi on in this case. But as Lady Ada showed in her video with other devices, if they aren't quite as power hungry, you should be able to get away with that hot swap. I'll actually give it a try, why not? This is, let's see, yeah, this is coming off of a USB port on my computer, actually on a little power strip that I don't think can cut it. But let's see, if I swap that into one of the higher current ports, I'm not even sure if this one has them. Let's see. Stand by. There we go. Okay, so maybe, I'm doubting it, but maybe I can pull the battery out and it'll stay alive. Let's find out. No, oh, it dimmed there? No, that turned off, so that was bad news for my Pi. I'm guessing that just rebooted. Yeah. All right. So interesting that this will run the 4, but it's a little power hungry for that hot swap capability. However, with other devices, you can totally use it as essentially an uninterruptible power supply, which is really cool. And you can integrate this into small little projects. Now, speaking of integrating into projects, let me just pop back to a main view here. And I'll show you, this is an old friend of mine. You might have seen this one before. This is the Lucioblaster project I built. And this is running that exact PowerBoost 1000C inside of it. So I integrated a little charging port here into the side so I can plug the USB cable in. It charges up the battery in there, which is one of these big, I think 6600 milliamp hour packs, these triple cell guys here like that. And then I have the enable grounded right now. If I flip this switch, it will tell the PowerBoost to go ahead and turn on and supply power. So now you can see this will kick into life, start playing its music and LEDs and sound effects. And all of that is being powered by our PowerBoost. So I can go ahead and flip that back off, boop, like that. So particularly for not for Raspberry Pi stuff where you want to safely shut down, but for microcontroller projects, this one's running off of, gosh, I can't remember. Maybe that's an Arduino Uno in there. No problem in those cases to flip stuff on and off, and you can use the enable pin, which means we're not running high current through the switch, so you can use really tiny switches. One other case where I've built a nice little integrated project with the PowerBoost. If I switch back to this down shooter here for a second. So this was a little 3D printed case I made for a 2-cell version of one of these batteries. So I think it's around 4,000 milliamp hour battery pack in there. You can see it's plugged into the JST connector. I can charge it through this little micro USB port here. In fact, let me steal that cable there, plug that in. So you can see there, that is now yellow, telling me that it's charging up the batteries inside. And the reason you're not seeing the blue light there is that it's not sending the 5 volts out this port right now. I can flip that little switch, little micro switch that I put on there, and that allows us to turn it on and off. Now in the final project, I have a little 3D printed extension to that switch there, so I can close this case up and turn that. Oh, I've misaligned it. I don't think that's gonna let me do it. But you can imagine if I put that together right, that'll flip that on and off. One nice thing about these compared to your average battery bank. So do I have one around here? I don't even have one. But your typical phone battery bank, they're great. However, they often will automatically turn off if there's not enough current being drawn. So it's difficult to keep really low power projects running with your average battery. Batteries. Speaking of batteries, sorry about that. I just lost audio because a couple of these regular old AA's that run my microphone wireless pack. So tell me, what did you lose? When did I stop talking for you? I will back up if necessary. Did you see me talk about the little battery pack? You tell me when that happened. Not back for YouTube. I think that'll catch up. Give it a second. There it goes. All right, so how far do we need to rewind? You tell me. These are the joys of live production. All right, let me know. I'm going to actually write that into a text chat. When did your average battery? Oh, okay, good. Not so far back. Whew, thank you. Yeah, I am attuned to not, if I don't see those little bumping meters in the back of my mind, I know something went wrong. So one nice thing about the PowerBoost 1000C compared to your average power bank, your average battery, is that it will not shut off when there's no current being drawn. So as long as we have the unit running, in this case by using that enable switch and ungrounding the enable switch, the device will power really low power projects, which you will often have if you're trying to run an Arduino or a Feather or something like that off of a regular power bank. If you're not drawing much current, they'll just automatically shut off. This will stay on. Also, this has the necessary resistors to keep iOS devices happy, which is great. So you can use this as, and that's actually why I built this one. I bring this on airplanes or used to in the before times. Bring this out and about just as my own little sort of personalized power bank. A piece of advice, actually, I heard this note from C. Grover earlier, who's used the PowerBoost, and he said, hey, one thing to watch out for is proper ventilation, because this can get pretty hot, especially if the battery's drawing a lot of current or if you're charging the battery. So, case in point, this started out life straight up and down. You can see there's a little bit of a warp and a bend in the PLA plastic there due to heat. So this, I should have put some vent holes in this. Partly it's just saggy because I have it mounted on there. But that design didn't allow for much heat to escape. So you do want to be a little more careful, at least have some space around it. I've never had problems with the Lucioblaster. There's enough space in there and there's some air gaps that it's worked fine. But you do want to be careful if you're sealing that up tight to make sure that you're not overheating. So iOS and some Android devices, says Doctor over in our chat. Yeah. All right, so let's see. Let me know if you have any other questions, but this is, let's pop over to Chrome for a second. This is where you'll find the device itself. Let me switch tabs here. And these are an astonishing 50% off right now, maximum of 10 of them. So if you have projects that need some boosting of 3.7 up to 5 volt, or 5.1 roughly, then and you want to do some battery charging along the way, this is a tough one to beat. Really great little power boost, and you can get it for $9.98 right now. Put it in your cart. That price is only good right now during the show. Once the show's over, that will end. So you'll want to hit go pretty quickly. Dave Odessa asked, what kind of filament did you use? This was some PLA plastic, probably from Ultimaker. This was some blue plastic I had a long time ago from my first Ultimaker. All right, and if you scroll down in here, you will get down to some projects made using the PowerBoost 1000, as well as the main Learn Guide, which is right here. And this tells you everything you need to know about it, the specifics about it, the pinout, how to put it together, especially if you're planning on adding a switch, a little on-off switch. This will guide you through it, as well as soldering on that USB port, which again, you can put different types of ports on there. You could probably use one of our little breakouts to make that USB-C if you wanted to. There's different options, since we just have pins on there that are not soldered when you first get it. So that's the basics on it. Not a lot to it. It's straightforward, easy to use, and works really well. So I think that's going to wrap it up for this week's product pick of the week. So I will encourage you to go grab 1 or 10 of them and help keep the lights on here at Adafruit, and help keep me in batteries for my microphone so we don't go silent. And thank you everyone for stopping by. I will see you all later in the Discord chat. For Adafruit Industries, I'm John Park. My product pick of the week has been the PowerBoost 1000C. Bye, everyone.